Morning. Welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner, and we're starting Chapter 7 today. Chapter 7 is all about rational expressions. So we're going to open up Chapter 7 explaining what those rational expressions are, evaluating them. We want to be able to determine if a rational expression is undefined. We want you to be able to simplify said rational expressions, and then we're going to look at a specific case of rational expressions where the factors themselves are opposites. All right, so what is a rational expression? A rational expression is an expression of the form A over B where both A and B are polynomials. Now, it's not interesting. Maybe you find it interesting, maybe you don't. But in the same way that fractions cannot have 0 in the denominator, the polynomial expression in the denominator, in this case our b value, whatever expression that might be, cannot be 0. So just like you cannot divide by 0 in a fraction, you cannot divide by 0 in a polynomial, right? Okay, our first goal is to just be able to evaluate these polynomials. This means, can you put in a number and check out an answer? So for our first example, we're just evaluating them. We have 2y plus 9 over y squared plus 6. So we're just going to plug in the value of y here at -2. So 2 times a -2 plus 9 over a -2 squared plus 6. If I simplify this, 2 times a -2 is -4 plus 9. -2 squared is -2 times -2 or 4 plus 6. That's not a negative there. That's just a little typo on my part. And this is going to give us 5 over 10, which would reduce to 1/2. And there we have evaluated our rational expression. In the second example, we actually have a cubed. So we have 3 times m cubed minus 5 over 5 minus whatever that m value is. Our m here is -5. Watch your order of operations. You want to cube that first. This will be 3 times a -125 minus 5 over 5 minus a minus, which is 5 plus 5. This is going to be a -375 minus 5 over 10, or a -380 over 10, which is a -38. And we have evaluated a second problem. Okay. Now, that brings us to the second goal. The second goal in this section is just to determine when a rational expression is undefined. Remember, I mentioned just a few minutes ago that even with a polynomial expression, you cannot divide by 0. So you cannot divide by 0. That means we spend a lot of time determining whether or not we have a 0 in the denominator. It's actually quite simple. We take whatever is in the denominator and we say, okay, when would that be 0? So if I have x minus 7, that's in my denominator, it cannot be 0. So our x minus 7 is equal to 0. So if I add 7 to both sides, this now tells me that when x is 7, our denominator is 0. So I'm able to determine what values of x will not make sense, will give us an undefined solution. An undefined expression. Undefined expression. Yep, that's what I wanted to say. Okay, so what about number 4? Well, in number 4, we have a quadratic here. We've got an x squared minus 6x plus 8 equal to 0. When all of that is equal to 0, I will be undefined, or the expression will be undefined, not the expression. So I need to determine, based on this equation, what values of x will zero this out. This is everything we did in chapter 6. This is that whole factoring and solving piece. So it's coming back into play here in chapter 7. So let's review. I need 2 numbers that multiply to give me a positive 8, but add to give me a negative 6. We can do this particular problem 2 ways. I'm going to go ahead and do the factoring by grouping first, but if you can do it using the mental math, that's all right. It's actually to your advantage here. All right, so in the grouping method, we would take the factors of a positive 8 that would add to give us a negative 6. Since it's negative, I know both of these have to be negative. It could be a 1 and 8. It could be a 2 with 4. Right, those are the factor pairs. Looking at these 2 factor pairs, it's the negative 2, negative 4 that works. So I'm going to break this negative 6 into an x squared minus 2x minus 4x plus 8. I'm going to look at the first 2 and pull out an x. I'm going to look at the second 2 and pull out a 4, but I'm going to make it negative because we led with a negative there. That leaves me x minus 2. X minus 2 is in both of those terms. So I can pull that x minus 2 up front, leaving x minus 4. So x minus 2, x minus 4 is equal to 0. Using the 0 factor property, I know that when 2 factors multiplied together give me 0, either the first factor is 0 or the second factor is 0. This means that x would be 2 or x would be 4. I added 2, and on this guy I added 4. So which values of x will zero out the denominator when x is equal to 2 or 4? That's when I would have a 0 in the denominator. Okay? All right. Now, this can get a little bit confusing, but we sometimes, instead of saying it this way, we ask what the restrictions would be. We ask you to determine the restrictions on these expressions. That simply means I'm wanting to figure out when I will get 0 in the denominator. So that will happen when the denominator is equal to 0. But we're not determining what k in this case can be. We're trying to determine what k cannot be. We want 3k plus 9 to not equal 0. So I'm going to change that equal 0 to a not equal, but I'm going to treat it just the same. I'm going to factor out a 3. Whoops. So now, using the 0 factor property, either 3 cannot be 0. Well, yeah, 3 can't be 0. 3 is 3. So this is okay. That's my check mark. Or k plus 3 cannot be 0. If k plus 3 is not 0, then I would subtract 3 from both sides. And I actually get the restriction on k. K cannot be a negative 3. K cannot be a negative 3. If k is a negative 3, then I have 3 times negative 3, which is negative 9 plus 9. Then I get a 0. So my strict restriction is that k cannot be a negative 3. Right? We can do this with any denominator. Any denominator we have, we do not want it to equal to 0. So here I have w squared minus 4w minus 21 cannot be 0. Now, just like before, this is a quadratic equation. We're going to want to see if it's factorable. So what numbers multiply to give us a negative 21, but when we add them, we get a negative 4. If I'm looking at a negative 21 and a negative 4, So that could be a negative 21 and 1. It could be a negative 7 and 3. I think it's the negative 7 and 3, right? So I'm going to go ahead and factor this using the mental math. That means that I recognize that when there's a 1 here, nothing or a 1, that my factors will end up being the W minus 7 and the W plus 3. Using the zero product property, either the first zero factor property, either the first factor cannot be 0 and the second factor cannot be 0. I would add 7 to both sides. I'm going to subtract 3 on both of these. So W cannot be a positive 7 and W cannot be a negative 3. So my restrictions are that W cannot be 7 and a negative 3. There. And I've got my restrictions. Okay. Restrictions occur when your denominator is 0. Third, that brings us to the third goal. We're going to use all of this in order to be able to simplify those rational expressions. In order to do that, we need the fundamental property of fractions, which basically says if A, B, and C are polynomials, and B and C are not 0, are not equal to 0. Right? We need our restrictions maintained from above. Then it must be true that A over C times B over C is equal to A over B. Basically, once everything is factored out, you can cancel. Whoops, everything is factored. Go ahead and cancel. Okay. That is the fundamental property of fractions. Once you know all the factors, go ahead and cancel. We do it with numbers. We can do it with the polynomials as well. We do need to make sure that our denominators are restricted, that we know what the zeros are. All right. So here is our strategy for simplifying these. 3 main steps. Go ahead and factor completely. Make sure you have completely factored the numerator. Make sure you have completely factored the denominator. Go ahead and cancel what factors can be canceled. Keep in mind, you can only cancel factors that are exactly alike. Do not cancel partial factors, right? If there's anything remaining, sometimes we will multiply them back together. The factors in the numerator that remain can get multiplied together. The factors in the denominator that remain can get multiplied together. And sometimes we'll just leave the factors because the multiplication is a bit of an extra step we don't need. All right? Okay, let's see this in practice. Okay, we are going to go ahead and assume for this particular problem work that none of our denominators are 0. So we're not having to worry about restricting them to start. We're just going to assume that all of the denominators are not 0. Okay, problem number 7. We have a 20x to the 5th y to the 8th over 15x to the 9th y to the 3rd. This goes back to our rules from before for monomials when we were dealing with the exponents and the bases. The same rules apply here. You can overcomplicate it, but let's not. All right, let's look at this and just look at the numbers. 20 and 15 are both divisible by 5. So I'm going to write down the extra step. So this would be 4 times 5 over 3 times 5. This is an x to the 5th. This is an x to the 9th, y to the 8th, y to the 5th. Notice I can cancel the 5s. So I will have a 4. The x to the 5th will cancel with the x to the 9th. Y to the 8th over y to the 5th would give me y to the 8 minus 5 or y to the 3rd. In the denominator, I have a 3. This would be x to the 5th over x to the 9th, leaving me x to the 4th. So this is 4y to the 3rd over 3x to the 4th. I have monomials here. I don't have binomials or trinomials. So this is just going to be a simple cancellation. All right, problem number 8. I have x squared minus 5x over 5x minus 25. Looking at the numerator, I recognize I can pull an x out of both of those, and I have an x minus 5 remaining. Looking at the denominator, I have a 5x minus 25. I can pull a 5 out, and I'm left with an x minus 5. Notice I have an x minus 5 in both the numerator and denominator. That factor will cancel out, leaving us just x over 5. All right. Problem number 9. We always want to factor first. Here we have an x squared plus 13x plus 12. I need two numbers that multiply to give me a positive 12, but add to give me a 13. If I look at the numbers that multiply to give me a positive 12, I notice that 12 times 1 will add to be the 13. So my factoring here would be x plus 12, x plus 1. That will give me the factors. Now, I did that one using mental math. If you need to do it using factoring by grouping, we can do that as well. I'll do another example using factoring by grouping. All right. The denominator, we have x squared minus 144. This is two terms. It is quadratic. I need all of the strategies from chapter 6. So this is a difference. This is a squared. Is 144 a square? If you don't remember, you can do the square root of 144. Yes. So this problem is the difference of two squares. Do you recognize that pattern? This means that the factors here would be an x and an x, and then the square root of 144 is 12. One of them will be positive, one of them will be negative. That then determines the two factors in the denominator. Now I can see I have an x plus 12 in both the numerator and denominator, so they will cancel out, leaving the factored form as x plus 1 over x minus 12. All right. Now, I can't cancel the x's. That's the one thing that people sometimes like to do is cancel those x's, because this in my numerator is technically inside parentheses, as is the denominator, right? That's where they came from. Do you see how they're inside the parentheses and inside the parentheses? So I can't cancel those x's. It doesn't work that way. Just don't do it. All right. Let's try problem number 10. We have a 3x cubed plus x squared. I can factor an x squared out of that. And then I'm left with a 3x plus 1 in my numerator. In the denominator, I have just a 3x plus 1. Or if you wanted, a 1 times 3x plus 1. I can't factor anything else out of there. But I do see then that I have a 3x plus 1 in both the numerator and denominator. So they will cancel out, leaving an x squared over 1, which is just x squared. There we are, factored. All right, let's try problem number 11. Problem number 11, in the numerator, I have two terms. I have an x cubed and a minus 27. Now, this is a difference, but these aren't squares. X cubed is a cube. So I want to check and see if 27 is a cube. Is 27 a cube too? 27, I need a third root. So I'm going to use 3. There we go, 27. Okay, so the cube root of 27 is 3. All right, so that tells me that I can use the difference of two cubes. I can use that pattern For practice, that would be an x minus 3, right? Because x cubed is x times x times x. 27 is 3 times 3 times 3. Okay. So that's an x minus 3. And then I use the squared, the opposite of the sign, plus the product of the two together, 3x, and then always positive, the last one squared. So same, opposite, always positive. So that's going to be 9. Great. And then as you hopefully remember, this particular trinomial is not going to be factorable. We can't factor that any further. That's prime. The trinomial here is prime. So it's done. Okay. All right. Then for the denominator, we have again a trinomial where we multiply to give 9 and add to give a negative 6. So what numbers multiply to give us a 9 but add to give us a negative 6? That's a 3 and 3. Oh, and 3 plus 3 is 6, but it's negative, so it's going to be negative 3 and negative 3. So this is going to be x minus 3, x minus 3. And I again used mental math on that because the lead here was a 1. Now, once I have this factored, I can see I have an x minus 3 in both the numerator and the denominator. That will cancel out. In the numerator, I am left with x squared plus 3x plus 9. It does not factor any further, so I cannot do any more. Over in the denominator, I have just an x minus 3. There is no entire factor in the numerator and the denominator that I can further cancel. So this is it, and I am done. Okay, let's look at problem number 12. Problem number 12, oh, that has leading coefficients. So problem number 12, I'm probably going to have to do a little bit of side work, as it were. Okay, so this one's going to be, I'm going to need to do a little bit of prep work. So let's look at the numerator separately. 6x squared minus 7x minus 5. Because I have a leading coefficient, I do have to factor by grouping. I mean, I can do some mental math on this. It's not my favorite way to do it, though. So, all right. So 6 times 5 is a negative 30. So what are the factors of a negative 30? See, this is negative. So it could be a negative 30 and a 1, a negative 15 with 2, a negative 10 with 3, a negative 6 with 5. Okay, those are all my choices. Which one of these pairs would add to give me a negative 7? Oh, well, that's the negative 10 and 3. So I'm going to break this negative 7x apart. I'm going to do 6x squared minus 10x plus 3x minus 5. Now, from my first two, I can pull out, they're both even, so I can pull out a 2 and an x. And that's going to leave me with 3x minus 5. For my second pair, I can't pull anything out. But I do notice that what's left is exactly this. So I'm going to do a plus 1, 3x minus 5. So now I've got 3x minus 5, 2x plus 1. Okay. So I know what my numerator factors into. And now I need to check the denominator. The denominator is 3x squared plus x minus 10. And if I do first times last on this one, oh, I get a negative 30 again. So that's going to be the same factors. All right, great. But this time I need them to add to a positive 1. This pair adds to a negative 1. So I bet if I did a 6 and a negative 5, that would add to a positive 1. So that's going to be 3x squared plus 6x minus 5x minus 10. So I can pull out a 3x, and I'm left with x plus 2. I can pull out a minus 5, and I'm left with x plus 2. So my factors here are going to be a 3x minus 5, x plus 5, right? Oh, x plus 2. There. Because I would pull this x plus 2 out front, 3x minus 5. Okay. All right, great. And then we're left with canceling the 3x minus 5 and 2x plus 1 over x plus 2. Okay, now, if you're doing this for a test, this factorization is expected for problems like these, either in the guess and the trial and check method or in this particular factoring method. I would expect to be able to see this. To jump from here to here without showing me any work or explanation generally tells me that you had some assistance in getting these factors, right? Right. Even if you're using mental math, knowing the minus 30 and listing the factor pairs could count as work for that. But nothing to go from here to here without all of this work. Nope. I'm going to ask you how you did it. I'm going to ask you how you got there, just as an FYI. Okay? All right. Now, that was a lot of work. There's a lot there. We still have one more goal to go. And that's simplifying these same expressions when your factors are opposites. So one of the things we have to sort of touch on is, what do we mean when we say polynomials are opposites? Basically, polynomial opposites mean the same terms with opposite signs. But not just opposite signs on some, opposite signs on all of them. So if we had an A plus B, then the opposite would occur if you took a negative 1 times that A plus B to get a negative A minus B. Do you see how that's opposite signs on all of the terms? Okay? So if you have a polynomial and you need to know the opposite of that polynomial, for A minus B, the opposite would be a negative 1 times that A minus B, which would be a negative A plus B, which we sometimes write as B minus A, putting the positive first. Okay. If I had 27 plus x, the opposite would be a negative 1. It's not 27. That's 2x plus 7 times the 2x plus 7, which would be a negative 2x minus 7. I don't have a positive to pull forward, so I would just leave that as it is. If we're doing number 15, to get the opposite, we're just going to take all of this and multiply it by a negative 1. That's going to give me a 5x squared. Negative times negative is positive. Minus 6x. Negative times positive is negative. And then a negative 1 times a negative 12 is a plus 12. Notice that all of the signs are the opposite, even though the terms are essentially the same. If I have 8 minus x cubed, in order to find the opposite, I would multiply all of this. Sorry, I wanted to do that in yellow, by a negative 1. That's going to give me a negative 8 plus x cubed. We will often write the positive first, which is the same as x cubed minus 8. All right. So, can you recognize when you have opposites? Let's take a look at problem number 17. If we're looking at problem number 17, the x minus 7 will stay exactly the same. This is x minus 7. However, in the denominator, do you notice that you have the same terms, the 7 and the x, but they have the opposite signs? So I recognize this 7 minus x as a negative 1 times that x minus 7. Now that I have the same in both the numerator and the denominator, I can cancel the x minus 7, and I'm left with a 1 over a negative 1, which is just a negative 1. Can't do anything more with it. If we're looking at problem number 18, we have an r plus 5 and an r minus 5. R plus 5, I can't factor anything out of, so that would just be an r plus 5. In the denominator, I have an r minus 5. The 5s are opposites, the r's are not. This does not fit any pattern. I cannot cancel anything. Both of the r's are a part of a larger numerator or denominator with addition and subtraction, so I cannot cancel out the r's. That means that this is simply not factorable any further. This is already in its lowest terms. Right? Okay, let's try problem number 19. Problem number 19 is h squared minus 1. Well, this may be factorable. That's a square. Is 1 a square? Yep, 1 times 1 is 1. And this is a difference. So this fits our patterning for the difference of two squares. And I should be able to factor this out. H squared minus 1 will factor into two factors, an h in the first and an h in the second. And then because this is squared, I will need a 1 here and here. The difference of two squares gives me different signs, h plus 1, h minus 1. Now in the denominator, I have 1 minus h. Notice that this 1 minus h is exactly like the h minus 1, but both the terms have opposite signs. So I'm going to factor out a negative 1. And then that's going to give me a negative 1 plus h. H plus 1, h minus 1, which is the same as a negative 1 times h minus 1. That's me showing all of the steps. Now I have h minus 1 in both the numerator and the denominator, and I can cancel it out. This gives me h plus 1 over a negative 1, which would be a negative 1, h plus 1. Good? All right. Let's try problem number 20. Problem number 20, in the numerator, I have 10 plus 3x minus x squared. I don't like that minus x squared, so I'm going to pull out a negative 1. And then that x squared will be positive. That 3x will be a minus 3x. And that 10 will be a minus 10. In the denominator, then, I have an x squared plus 3x minus 40. Okay. These are both quadratic. They are trinomials. I do need to try and factor them. So using the mental math, because these both start with a 1, right? I don't need to use the grouping all the time if it starts by 1. What are the factors of a negative 10 that will add to give you a negative 3? Negative 10 could be a negative 10 and 1. It could be a negative 5 and 2. So I see the negative 5 and 2 will add to be a negative 3. So this can be a negative 1. We'd have an x, and we'd have another x. That'll give us our x squared. We need a 2 and a 5 to give us our 10. The 2 will be positive. The 5 will be negative. That will get us the negative 3. All right? For the denominator, I have an x squared plus 3x minus 40. So now I need what will multiply to give me a negative 40, but add to give me a positive 3. Since it's a positive 3, the larger number will be positive. So it could be 40 times a negative 1. It could be 20 times a negative 2. It could be 10 times a negative 4. It could be 8 times a negative 5. We'll look at that. 8 and the negative 5 works. 6, 7, nope. All right, so when I factor it, I'll have an x and another x. To get the 40, I need 8 and 5. To get a positive 3, this needs to be a plus 8 and a negative 5. Do you see that in the factors I have an x minus 5 in both? So I can cancel that x minus 5 out. And I have a negative 1, x plus 2 over x plus 8. Because these are fully factored, I cannot cancel the x's. This is as far as I can go. I would note that sometimes you will see a negative out front here, and then people will do the x plus 2 over the x plus 8. I'm not a huge fan of throwing that negative out front, simply because it gets lost. So I kind of prefer this method of writing the answer, but there's nothing wrong with this. I just worry that I'll miss that negative because it's right on the same line as that fraction bar. So I prefer to see it this way, but there's nothing wrong with this one, right? All right, that gets us through all 4 of the goals for this particular section. We have evaluated rational expressions. We've determined when they're undefined. We've simplified rational expressions, including ones where factors were opposites. If you have any questions or concerns, please don't hesitate to reach out to myself or to stop into the Math Center and see if Julia or any of the myriads of people there can assist you with your problems. All right, thank you. Bye.